Okay guys, back with another lesson. If you hear my dogs in the background, please forgive me. They are riled up. All right, so yesterday we started section 4.4 and it was involving complex numbers, the imaginary number, and we added, subtracted, multiplied, and did powers. And in all those situations, you just treat I, the imaginary number, like a variable, except when you have I squared, you make it -1. I to the third power is -I. So we need to keep that in mind. Where should I do this? I'm going to do just a little thought bubble off to the side. Just remember, I is the square root of -1. I squared is -1. I to the third, honestly, is not going to come up today, but just for the sake of being thorough, that's -I. So we've got the definition of the imaginary number, and then I squared and I cubed. So today we're working with complex numbers, so that's a real part plus or minus a real number times the imaginary number, which together is called the imaginary part. We are just going to focus on dividing them today. So dividing is complicated, that's why it wasn't lumped in with yesterday's lesson. Generally speaking, I, the imaginary number, should never be in the denominator of a fraction. If you have I below a fraction bar, you need to divide it. And you probably know a fraction bar basically means divide anyway. But with complex numbers, dividing is actually referred to as rationalizing the denominator. And we're going to be talking about rationalizing the denominator off and on throughout the school year from now on. It comes up in other scenarios too. But for now, just complex numbers, that's all we're worried about. There are two general scenarios. In one scenario, the denominator, the bottom of the fraction, is a monomial, meaning there is just one term. When that happens, you multiply your fraction by I over I. Now keep in mind, in fractions, if you ever have the same thing on top as on bottom, that's just 1, right? 5 over 5, 8 over 8. Excuse me. So over here, I over I is just 1. And when you multiply something by 1, you don't change it. So take any number like 15, multiply it by 1, of course you still get 15. So when you multiply by I over I, you're not changing the value of the number. You're only multiplying by 1. But what you're going to do is you're going to change the appearance or the form of it. And that's what the lesson is all about, is how to do that. So if the denominator is a monomial, multiply by I over I. That's going to be about half the lesson. Second half of the lesson is if the denominator is a binomial, meaning there's two terms. When that happens, you don't multiply by I over I. Look at that. It's a little more complicated. You multiply by the conjugate of the denominator over the conjugate of the denominator. Again, it's the same thing on top and bottom. When you multiply the top and bottom of a fraction by the same thing, it does not change its value. The value stays the same. The form will change. The way it looks will change. Now, conjugate of the denominator. So yeah, let's make a phrase, not even a sentence, with a whole bunch of big words in it. Right, denominator, you know, that's the bottom of a fraction. Conjugate is new. So let's talk about conjugate for just a minute. As you know, a complex number has this form, a plus bi. I just talked about it up here, a plus bi. The conjugate of a plus bi is a minus bi. So really, conjugate is the exact same thing, only you change the plus sign to a minus sign. So if you have 6 plus 4i as an example, the conjugate is going to be 6 minus 4i. So there, the definition of conjugate is pretty easy. What about trick questions? What if it's already a minus right here? 8 minus I, what's the conjugate of that? Well, it's just 8 plus I. So whatever sign is in the middle, you just flip it. How about -2 plus 5i? What if there's a negative here? Yeah, it literally has no impact at all. -2 plus 5i, the conjugate is -2 minus 5i. It's only the middle sign that changes. That fact that that was a negative just stays a negative. It's no big deal. All right, so the rest is examples. If you didn't understand a bunch of what I just said, it's okay. As I go through examples, hopefully you'll pick up on it and you'll see what I mean. But as I said, there are two scenarios. One, the denominator is a monomial. That's all the way to here. The whole first page is scenario 1. I'm going to write that here. Scenario 1. And then after that is scenario 2, where the denominator has 2 terms. See, 1, 2. All right, let's get at it. So in scenario 1, the denominator is a monomial. You are supposed to multiply by I over I. Again, you're never supposed to have I in the bottom of a fraction. It can't be there, so we're going to divide it. But instead of calling it division, we call it rationalizing the denominator. So multiply by I over I. On the top, well, remember, when you multiply fractions, you just multiply straight across. 4 times I, 4I. Negative 7I times I is negative 7. Now, what's I times I? That'd be I squared. But remember, from yesterday, anytime you have I squared, you must turn it into a negative 1. This is a big deal. Such a big deal, I'm putting a box around it, for crying out loud. And I'm going to highlight it. Highlight it in, oh, I don't know, green. There, big deal. So, this becomes 4I over negative 7 times negative 1. I changes into negative 1. Finally, you can simplify that. The top is just 4I. The bottom, negative 7 times negative 1 is 7. 4I over 7 is the answer. Let's check number 2 and make sure. 4I over 7. There it is. So that's rationalizing the denominator. Next one. Again, you've got I in the denominator. There's just one single term here. So we multiply by I over I. Top times top, that's negative 3I. Bottom times bottom, that's negative 2I squared. The fact that you have I squared means you must change it into negative 1. That ultimately becomes negative 3I over, what, negative 2 times negative 1 is positive 2. And that should be the answer. However, it is common when you have a negative sign in a fraction to pull it out sort of level with the fraction bar instead of leaving it up there like where that 3 is. Let's see which way the answer is written on number 4. Yep, there it is. Negative 3I over 2. Number 6. Again, the denominator is a monomial. Now I do see that the numerator is a binomial, but that doesn't matter. The denominator is a monomial. That means it's scenario 1, you multiply by I over I. On the top, we actually have to do the distributive property. We get negative 6I minus 8I squared. On the bottom, if we multiply these together, we get 7I squared. Once again, you have I squared. It must turn into a negative 1. So that's negative 6I minus 8 times negative 1 over 7 times negative 1, which becomes negative 6I plus 8 over negative 7. And I bet that's not what the answer looks like. For one thing, this is probably going to be flipped around because we normally put the real part first. Oops. And then the imaginary part minus 6I second. And now I said when you have a negative, it's typically brought out front like this. But in this scenario, probably that negative 7 is going to reduce. So here's what you do. Remember that this is a positive. If you have a positive divided by a negative, that equals negative. You have a negative divided by a negative, that changes to positive. And then the bottom just turns into 7. So that should be the answer to number 6. And there it is. If you left your answer like this or like this, you would not be wrong. It's just not completely simplified. So yeah, if you get a negative like that in the denominator, just divide it into the numerator. Just make sure you divide the negative into both terms. If that happens again, I'll point it out. Yeah, it's going to happen again on number 8. Okay, so number 8, multiply by I over I, just like the last few problems. On the top, we actually need to distribute that. 5 times I is 5I, plus I times I is I squared. The bottom, 4I times I is 4I squared. Once again, both instances where we have I squared, those will turn into negative 1s. So 5I plus negative 1 over 4 times negative 1. Okay, so 5I plus negative 1, that's the same thing as negative 1 plus 5I. Put the real number first, the imaginary number second. On the bottom, 4 times negative 1 is negative 4. And then last, divide this negative into both upper terms. Negative 1 divided by negative 4, well, the negatives give you positive. Positive 5 divided by negative 4, positive divided by negative equals negative 5I over 4. And that should be the answer. So this cancels with that, and it changes that. So number 8. Oh, wow, they left the imaginary part first. Oh, they did that on number 6 too. Okay, well, that's weird. Looks like some problems they do put it second, and some problems they do put it first. So, all right. I hope that isn't too confusing for you. You know that like 5 plus 3 is the same thing as 3 plus 5. So technically speaking, if you had something like, well, what do we have in this answer? I had 1 minus 5I. They had negative 5I plus 1 because that's a positive. You switch them around, it's the same answer either way. Personally, I think it's better to have it this way, but whatever. Don't stress it. Okay, so that is all scenario 1, where you multiply by I over I. Scenario 2 involves this conjugate thing. Multiply by the conjugate of the denominator over the conjugate of the denominator. So this is going to be more complicated, and we've got, well, 4 of those to do. So, number 10. Conjugate of the denominator. The denominator is negative 10 minus 10I. The conjugate is going to be negative 10 plus 10I. So we need to multiply by this. All right, so what happens here? When the numerator, we distribute, and we get negative 60I plus 60I squared. On the denominator, this is going to get ugly. I apologize. We're going to have to FOIL this. First, negative 10 times negative 10 is 100. Outside, negative 10 times 10I is negative 100I. Inside, negative 10I times negative 10 is positive. 10 times 10, 100I. And last, negative 10I times positive 10I is negative 100I squared. Let me pause there for just a second. We distributed the top, and we FOILed the bottom. Now there's several things that are going to happen here. First of all, both of these I squareds are going to have to turn into negative 1. Remember, it's so important to put a box around it. I squared always equals negative 1. Secondly, in the bottom, do you see the middle terms here, how you get minus 100I plus 100I? Well, those are opposites. They're just going to cancel each other out. So what does that give me? Negative 60I on top plus 60 times negative 1 all over 100 minus 100 times negative 1. Can I simplify that any further? Yeah. Negative 60I minus 60 over 100. Let's see, when I do this, that turns into 100 plus 100. So that's negative 60I minus 60 over 200. Now, I can do even more. 60, 60, and 200. That can be reduced. Now, if we just had 60 over 200, forget the imaginary number, forget I, all that stuff. Let me write this a little more neatly. There's one trick you might have learned, like, oh, you can just cross out the zeros, which is true, but that leaves you 6 over 20. You can reduce 6 over 20 by 2, and that's going to give you 3 over 10. Or if you don't do the zero trick, you could say, well, you can divide this by 20, and you can divide this by 20. 60 divided by 20 is 3. 200 divided by 20 is 10. 3/10. So there, reducing fractions. When you have a fraction with 3 parts like this, we've got one term, a second term, a third term, You can still reduce it, but you have to reduce all three of them the same. So that means I need to reduce this 60, and this 200. I have to reduce them all by 20. So if I divide this by 20, I'm going to get negative 3i. If I divide this by 20, minus 3. If I divide this by 20, over 10. That should be the answer, or possibly it could be written like that, because remember, you can switch these around. All right, that number 10 was really complicated. Wow. There it is. So it did not get switched around. I'll go ahead and just erase this part of the answer. There it is. Oh gosh. Okay, circle that, done. So that was a lot of work. You have to know what the conjugate of the denominator is. You got to multiply it on top and bottom. On top, that involves the distributive property. On bottom, that involves FOIL. Then you combine like terms. You make I squared negative 1. You combine more and then reduce the fraction, and it's a complicated way of reducing. What can we do to make this easier? There are a few things, and I don't think I'm going to go back and redo number 10. I don't think you want to see that, just to show you some shortcuts. But when we do number 12, I will do a shortcut here to try to help you out a little bit. All right, so rationalize, divide by a complex number. So we need to multiply this by 3 plus, oh no, sorry, conjugate 3 minus 3i, and then 3 minus 3i. All right, no shortcut yet. The top, I do have to distribute this. I get 30 minus 30i. On the bottom, when I go to FOIL this, okay, first is 9. The outside is going to be negative 9i, and the inside is going to be positive 9i. And what's going to happen with negative 9i plus 9i? They're going to cancel out because they're opposites. It turns out whenever you multiply conjugates together, the outside and inside always give you opposites. Up here we got negative 100i plus 100i, and they canceled out. So when you multiply conjugates, and you're doing the FOIL method, it turns out the outer and inner steps always cancel each other out anyway. So as a shortcut on these problems, just these problems, you can do first and last. So first times first is 9, which I have written down. Last times last is going to be negative 9i squared. So there's a shortcut. It saves us some of that work in the whole FOIL method. All right, next shortcut. What I've done in every problem so far is I've done this. On the bottom here, remember, if you ever have I squared, you have to make it a negative 1. So I've done this, 9 minus 9 times negative 1. Well, I bet you could do that in your head. If you could just say to yourself, okay, self, this is a negative 1. What's a negative 1 times a negative 9? Well, it's going to be plus 9. So essentially you can say I squared just changes that sign to its opposite. So what we end up with is 30 minus 30i over 18. Last, we need to reduce this, and I don't know, there's no real shortcut here. You just got to reduce it. What can you divide out of 30, 30, and 18? 3 might jump to mind, that's right, but when you reduce, you want to go for the highest number possible. You can divide a 6 out of all of those. If you divide everything by 6, you end up with 5 minus 5i over 3. And that should be the answer to number 12. There it is. All right, let's do those shortcuts again now on number 14. Ooh, now this one, we have binomial on top, binomial on bottom. Here, it was just a monomial over a binomial. So, okay, I introduced you some shortcuts just in time because this problem is going to be more complicated. So we need to multiply top and bottom by the conjugate of the bottom, 9 plus 7i. You might say, well, what about the conjugate of the top? No. We don't want to change, we don't want to mess with that. Just no. We only want to get the imaginary number out of the bottom. You only focus on the bottom, the denominator. So multiply by 9 minus 7i, multiply 9 minus 7i by 9 plus 7i. Again, You can foil it. I mean, if you enjoy doing the FOIL method, that's how your life runs, you know, so be it. But I'm just going to go first times first, last times last. That's a 49, not a 4a. 7 times 7 is 49. I times I is I squared. On top, sadly, we are going to have to do the whole FOIL. So first, 63. Outside, what's 6 times 7? Positive 42i. Inside, 9 times 9 is 9 times 10 is positive 90. Wow, I cannot speak all of a sudden. Last times last, 10 times 7, positive 70 I squared. Now, those are like terms that I can put together. 42 plus 90 is 132. I squared is negative 1. Negative 1 times 70 is just going to be minus 70. On the bottom, we've got 81. I squared again is negative 1. Negative 1 times negative 49 is plus 49. And I guess I can do one more step. Combine those as like terms. 63 minus 70 is negative 9. And then on the bottom, 81 plus 49 is 130. And I do not believe those numbers reduce. Which one did I just do? 14? That is not the answer to 14. Holy cannoli. What happened? All right, give me a second. Oh, I'm dumb. Oh, there goes my dog. All right, my problem is right here. What a maroon. Okay, if I've said that in these lessons and you have no idea what I mean when I say what a maroon, I'm saying what a moron. But maroon is mispronouncing moron because, like, you know, I'm dumb and maroon is a color, so therefore it's silly and funny. All right, is 6 times 9 63? No, 6 times 9 is 54. And now we have a 54 right here. 54 minus 70. What's 54 minus 70? You know, I should have just used a calculator. 54 minus 70, I believe, is 16. Hold on, I'm so afraid now I've made one mistake. I'm going to keep making more mistakes. Yeah, we're doing good. Okay. Now, can I reduce 16? Oh, I'm sorry, that's going to be negative 16. There we go. Yeah, because 70 is negative. Negative 16. Can I reduce 16, 132, and 130 by anything? Well, they're all even numbers. You know you can divide even numbers by 2, right? Yeah, so you got to do that. Negative 16 divided by 2 is negative 8. 132 divided by 2 is 66. And 130 divided by 2 is 65. So that should be the answer to number 14. And there it is. Wow. So I made, what, a third grade mistake? Awesome. No. So you learn from my mistakes. Use a calculator if you have any doubt about times or whatever. But there it is. So that was pretty complicated. Number 16, also complicated. So it looks like you're going to have 2 of these really complicated ones for homework. And then before that, I really hope you see that they're not quite so bad. All right, let's do this last one. So rationalize the denominator, or divide by the complex number. I need to multiply this by the conjugate. So it's 4 minus 2i, 4 minus 2i. In the numerator, I have to do the whole FOIL method, and hopefully I don't make any more third grade mistakes. Negative 5 times 4 is negative 20. Negative 5 times negative 2i is plus 10i. Negative 9i times 4 is negative 36i. Negative 9i times negative 2 is positive 18i squared. I hope that's right. On the bottom, I could FOIL, but all you have to do with conjugates is the first and the last. Cool. Next, we need to simplify. These are like terms, and you can combine them together. So that gives you negative 20 minus 26i. Also, don't forget, I squared is negative 1, so that plus 18 is going to turn into minus 18. On the bottom, 16 minus 4i. Okay, I squared is negative 1, so that's going to turn that negative into a plus 4. We can put the 20 and the minus 18, sorry, the negative 20 and the minus 18 together. That's negative 38 minus 26i. On the bottom, 16 plus 4 is 20. And then can you reduce this fraction? 38, 26, and 20. Those are all divisible by 2. So divide them all by 2. You get negative 19 minus 13i over 10. All right, I'm literally crossing my fingers. You can't see it, but I am because I want to... there it is. Perfect. Okay, so not necessarily an easy thing to learn. It's all brand new. There's lots of steps, some very complex parts to it. Starts off pretty easy. You have to remember, anytime you get I squared, it's negative 1. Don't forget, when you FOIL conjugates, you can sort of skip this step right there if you want to save yourself on some work. But that's it. Do this. Don't forget to show your work, check your answers, and please email me or write a comment if you have questions or you need help. All right, talk to you later.